So hello everyone. Today I will discuss the coordination chemistry, which is very important topic of class 12th. And in this topic, mainly coordination compound and their properties were discussed in details. So first of all, what is the meaning of coordination compound? So if you see the addition compound, first of all you should be know the addition compound, because the coordination compound is a type of addition compound, and addition compound is two type. First one is the double salt and the second one is the complex compound. Okay, so if you see the double salt, then double salt is very complex in nature, you can say. And if you dissolve in the solution, aqueous solution, then this type of salts loses their identity. Okay, means if you addition compound in which simple salt don't lose their identity, and their aqueous solution give test of all the constituents ions. ठीक है, तो यहाँ पे डबल साल्ट लूज देयर एंटी एक्वस solution. So it is a very important point. It is the actually it is mentioned wrong. So double salt loses the identity in the aqueous solution. So example is given here. So you can see the example of this is the carnallite KCl MgCl26H2O. So when dissolved in the aqueous solution, then it breaks in the potassium, magnesium plus 2 plus 3 chloride and iron produces, means number of ion will be the 5. Okay, so if you for detection of chloride ion that it is present or not, then you can add the silver nitrate. Then what happens, chloride attached from the silver and it forms the AgCl, which is 5 precipitate. Okay, so carnallite is a double salt, and if you dissolve the aqueous solution, it breaks into its constituents, and their constituents can be identified by using the different types of reagent, you can say. The second one is the you can see the NS4 Mohd salt, FeSO4 NS4 ka whole twice into 6H2O. So if you breaks down, if you dissolve in the aqueous solution, then it breaks into the 2 NS4 plus Fe2 plus 2SO4 minus 2 and 6H2O. So for ammonium, detection of ammonium and sulfate ion can be carried out by Nessler reagent and BaCl2 solution. So National reagent, when it reacts from the ammonium, it form the brown PPT, and sulfate react from BaCl2, it form the BaSO4, which is white in color. So you can identify the component which are present in that compound when dissolved in the aqueous solution. So if you see the third point, all alums are the double salt. Okay, so jitne bhi alums हैं, it is the double salt. So I think you will aware from the addition compound. It is very important. Sometime have been asking the in the CBSE board, but question can be arise from this part very much from for the NEET exam as well as IIT mains and advanced. Okay, so the second one is complex compound. So complex compound, if you see which do not give test of all the constituents ion. So if you see addition compound, anyways, simple salt loses their identity. ठीक है, simple salts loses their identity and its aqueous solution doesn't give test of its arc. मतलब क्या है, their identity remain constant. So okay, so next line it is mentioned that complex compound don't lose their identity in aqueous solution, जबकि while double salt lose their identity, complex compound don't lose the identity in the aqueous solution. Okay, so K4FeCN का whole 6, it breaks down when dissolved in the aqueous solution, 4K plus and FeCN का whole 6 and 4 minus. Okay, because 4 potassium is there, so 4 minus is mentioned is. Okay, so FeCN का whole 6 4 minus does not ionize to give Fe2 plus and Cn minus ion. Okay, so so in this you can check your mind that the double salt and complex are you understand or not. Okay, so again if you see the classification of complex compound, then it is the on the basis of ligand it is divided further. So you can see this is the on the basis of type of ligand. Homoleptic, same type of ligand है, it is called homoleptic. And homoleptic means क्या है, ligands are same type within the coordination sphere. ये आपको coordinate जो brackets दिया, it is the coordination sphere. So in coordination sphere only single type of ligand if present, then it is called the homoleptic complex, and if different types of ligands are present, then it is called heteroleptic complex. Okay, so in coordination sphere central atom and and ligands are present. You can see this one, okay, very carefully you can see. So again, if you see heteroleptic, so platinum is the central metal, ns4 का whole thrice, ns4 ns3 का whole 4 cl, it is the ligand. So there are different types of ligand, one is the ns3 and cl, so two types of ligand are present, so that's why it is called heteroleptic complex, different types of ligand, okay. So on the basis of degree of dissociation, it is divided into perfect and imperfect complex compound. So perfect complex compound, what is this? So relatively more stable and aqueous solution does not give test of all the constant sign, okay. So it is the stable perfect complex compound are always stable compound, while imperfect compound, they give the test in the if you dissolve the aqueous solution, okay. So you can actually this on the basis of degree of dissociation, I think it is an NCID, it is not mentioned, but you should be know about that, okay. So again, if you see uh, coordination sphere, representation of complex compound is very important part because it is a basic for all. So if you see coordination sphere, then in coordination sphere, one is the metal and other is the ligand are present, and the charge is mentioned on this top, okay. So how many charges there, it is mentioned on the upper portion of the coordination sphere. So coordination outside the region, ionization sphere, outside region means it is the ionization region, free ions and cations are present in outer portion of coordination sphere. Naming of ligands. So if you see O suffix provided to the name of anionic ligands, IM suffix to provide the name of cationic ligands, and anionic ligand ending with "ide" are named replacing "ide" with suffix O, replacing E by O. Ligands whose name in "ite" and "ate" become "ito" and "ato" by replacing the ending E and O. So you should be if you apply in for naming the organic compound, you will understand properly. So first of all, you should be know about the ligands. What is the types of ligands? So on the basis of identity, they are monodentate ligands, and monodentate ligands, some are neutral, some are neutral. So you can see in H2O it is the aqua, NS3 is the amine, CO is the carbonyl, CS is the thiocarbonyl, NO is you should be knowing nitrosyl. Methylamine, it is the CS3NH2, urea is NH2CONH2, NH2NH2 is the hydrogen. So phosphine, you can see the chemical formula PS3, PPS3 triphenyl phosphine, O2 is the dioxygen, dinitrogen, pyridine. So these are all the you can see these are the monodentate ligands, and since there are no charge, so it's the neutral ligand, okay. Cationic ligands, if cationic charge is present on the ligands, then it is known as cationic ligands, and monodentate in this O2 plus NO plus or NH2 NH3, it is the cationic ligands. So it is the monodentate. If you see the anionic ligand, then fluoro, chloro, bromo, iodo, oxido, nitro, N3 azido and hydrodo, ठीक है, hydrido, sulfido, hydroxo, methoxo, superoxo, peroxo, nitrido, N-3, it is the nitrido, amido, NH2 minus. Okay, so you should be know about the monodentate ligands. So all these type of the monodentate, some are neutral, some are cationic, and some are the anionic ligands. So again, if you see the bidentate ligand, then it is the ethylene diamine. Simple representation is En, and you can see the structure of the ethylene diamine. It is the ethane 1 to diamine, and it is forming the chelate ring because it bind with the central metal and forming the bulky molecule. So it's forming the chelate ring, and it is the symmetrical complex because if you divide from its central point, then it can divide it into two parts, equal parts. So it is the symmetrical complex forming. Dipyridyl, if you see the dipyridyl, then pyridine attached from the metal. Dipyridyl means there are two pyridine ring, and this is the pyridine ring. Benzene attached from one nitrogen, which are attached further to the metal. So there are two pyridines, then it is known as dipyridyl. Glycine, it is made up from the glycine, and glycine is the bidentate ligands. One is the site oxygen can donate the charge, and NH2 also donate the lone pair of electron to the central metal. In central metal, so that's why central metal is called Lewis acid, while Lewis base is called ligands is known as Lewis base. Propylene diamine, it is the PN, and oxalato, it is the oxalic acid. If we remove the two hydrogen from the oxalato. Dimethyl dimethyl glyoxymethyl is a DMG. Okay, so these are the important bidentate ligands. Some are the polydentate ligands I have mentioned here. All bidentate and polydentate ligands are the chelating agents. So chelate forming means if bulky ligands binding the central metal, then it forms the ring like a structure which is uh, so it is known as chelate. Okay, so number of chelate ring you can identify denticity -1. Okay, so again diethylene triamine, it is the denticity is 3, number of ring it will form the 2, and it is a neutral ligand. Okay, again you can say triethyl tetraamine, so denticity is 4 and the chelate ring forming 3, and it is the neutral. Terpyridine is the denticity is 3, chelate ring forming 2, and it is the neutral ligand. So you can calculate the how many chelate ring will be formed. So denticity -1 करोगे तो आपको chelate ring will be appear in this. ethylene diamine tetraacetato ADTA. Okay, so it is the density is 6, chelate ring forming 5. Ethylene diamine triacetato, density is 4, chelate ring is 4. Next is the ambidentate ligand. It's very important part, ambidentate ligands. So ambidentate ligands which have two different donor atoms, but at a time coordination such at a time of coordination such ligand can be coordinated CMA by either of the two donor atoms. Okay, so you can see cyanato. If you see CN, so there will be either N will be bind from the metal, either C will be bind from the metal. So cyanido, it is the CN. Isocyanido is the NC. So cyanido in this parts carbon will be attached from the metal. In isocyanido then then nitrogen will be attached from the ligand. So ONO is the another ambidentate ligand. Two sides, oxygen and nitrogen, is present in the ONO and NO2. So it is the bidentate, it is the ambidentate ligands. The next is the OCN and NCO. OCN is the cyanido, isocyanide is the NCO. Okay. So fluxidentate, what is the meaning of fluxidentate? So ligand fish can change their denticity. It is known as fluxidentate. So fluoxetine ligand fish can change their denticity is the CO3 minus. Okay, PO3 PO4 minus 3 SO4 sulfate CS3 acetate nitrate is the fluoxedentate ligands which are okay. So next is the how you can determine the oxidation state. So if you want to calculate the oxidation state of any central metal, then you can calculate by this formula, means no, in which you want to calculate the oxidation number. You can write down the X plus neutral ligand having the 0 oxidation state and minus sulfate having the -2 charge. Okay, so it is 0. So you can calculate the coordination number will be number of ligands present in the coordination sphere, is known as coordination sphere. Okay, so on the basis of electron donating electron accepting nature, you can divide the ligands are different types. Normal ligand are classical ligands which can donate electron pair to the central metal atom and form coordinate sigma bond. Okay, so in coordination compounds coordinate bond are present. So you can see these are the classical ligand. Non-classical ligand which donate electron pair to the CMA and form coordinate bond, but simultaneously they accept electron pair from the CN through back bonding. Okay, so back bonding is also known as synergic bonding. So these are the some ligands which form the synergic bonding: COs NO plus CN minus C6S6 C6S5 minus C2S4. So in this back bonding are present. It is very important. Non-classical are pi acid or pi accepting ligands. So again, if you see pi donor and pi acceptor ligands which donate pi electron to the central metal atom and also accept electron density from CMA through synergic bonding. So phenyl and cyclopentyl ligands synergic bonding are present, and they are pi donor pi acceptor ligands. Then ferrocene is the another pi donor ligands. You can see this one, and it is known as hapticity eta n. It is the eta n is known as, if you see this one, it is known as eta, and it indicates the number of carbon present on that molecules or ligand. You can see coordination number of ligands present, or number of electron accepted by the central metal atom, is known as coordination sphere. Nickel, it is the 4. Platinum is the 4 because triethylene diamine. Okay, so ligands, number of ligand is 4. EDTA, it is the EDTA is hexadentate ligands. Ethylene diamine is the 2 and 2 oxalate 2. Okay, ethylene diamine there are 2, so 2 and 2 को multiply करोगे 4, and oxalate is the 2 donor site or 6 coordination number it will be. And some important point, generally coordination number of monovalent cation is 2. Okay, generally coordination of monovalent cation is 2 and 4 except copper. Okay, you can see this one. Generally coordination number of bivalent cation is 4. Okay, coordination number bivalent cation is 4. Monovalent cation, it is the 2 and 4. Okay, so it is the some tricks you can see this one. And generally coordination number of trivalent cation is 6, some exception. Okay, coordination number of tetravalent cation is 4. Coordination number of CMA depends upon the charge of CMA 6 and CMA size of ligand, concentration of the ligands. Then so it is my first lecture regarding the some concepts of the coordination chemistry, and the second lecture I will discuss the remaining part, which is very important, like that effective atomic numbers, Sedgwick rule. Okay, and some IPAC nomenclature, you can see this one, and valence bond theory. Okay, so the remaining part I will discuss in the second lecture. It is the basic lecture, you should be know about that. And if you understand this basics, then you can also read the remaining part. So in the next lecture we will discuss the remaining part of this chapter. Okay, so thank you for